because 3 is the biggest degree. This doesn't have to be in this order. I could try to trick you and go negative 5x squared plus 7x plus x cubed. You're just looking for the one that's the biggest power. This is cubed, so it means it goes up or down up or up down. Then I'm going to look out front. I'm going to look out front and say there's a positive 1 there. Whenever I'm looking at odds, I'm picturing a line, because x to the first is an odd degree polynomial. If x to the first has a positive out front, it has positive slope. So if this was just a line, it would do something like this. Well, because it works for a line, it will work for our equation. Positive slope means that my ends are going to look something like that. They're going to go down and then up, just like positive slope would. Now I just need to find the zeros in between, and I can connect all those lines and finish this off. Well, the first thing I told you was 1 is a root to save you some time. So we're just going to use synthetic division to divide 1 into it. Well, I have 1x cubed, negative 5x squared, 7x, and negative 3. We'll carry down that 1. 1 times 1 is 1. Negative 5 plus 1 is negative 4. Negative 4 times 1 is a negative 4. 7 minus 4 is a positive 3. 3 times 1 is 3. Comes out to 0. Whew. I did it right. That's a factor. And so now what I'm actually doing is I'm factoring this. I'm going to bring this 1 down. Since 1 is a root, we'll have x minus 1 is a factor in there. The rest of it's going to be 1x squared minus 4x plus 3. I'm going to set that equal to 0 because I'm looking for my zeros. Well, that's going to be x minus 1 times, I can factor this to x minus 1, x minus 3 equals 0, because negative 1 times negative 3 is a positive 3. Negative 1 plus a negative 3 is that negative 4. I'm also going to note I can kind of push together those x minus 1s, because it's x minus 1 times x minus 1, so it's x minus 1 squared. I think I'm going to do that up here. I should have room to do everything. So I'm going to rewrite it one more time as x minus 1 squared. X minus 3 equals 0, because I need to know what multiplicity those numbers have. That's what I'm factoring in. I'm going to put x minus 1 squared to note that I have even multiplicity. It has even multiplicity, so it's going to be tangent. It's going to bounce off. This one's actually a 1. It's x minus 3 to the first power. That is odd, so it's going to go right through it. It won't bounce off. It'll actually go through. All right, that's all the information I need. I just need to know what my end behavior is, where my zeros are, and what happens at those zeros. So we start low, we end high, we bounce off x equals 1, and we're going to go straight through where x equals 3. Maybe I'll mark those down below. So I'm looking at x equals 1 and x equals 3. So let's go ahead and do our graph, and then we'll be done. 1 and 3, so let's move our x-axis over here, or y-axis over here. All right, I need to get the 3, so I'll go 1, 2, 3. Mark my 0 at 1. Mark my 0 at 3. From our leading coefficient test, we know we're going to start low. And we're going to work our way up to that 1. As I'm working my way up to my 1, I'm just asking, does it bounce off or does it go through? Since it's even multiplicity, it's going to bounce right off and come back down. So it's tangent, it goes dink. Then it's got to make its way back up to 3. At 3, x minus 1 to the first power, it's odd multiplicity, so it's going to go through. And that's what our graph looks like. It's important that you can make these graphs. All right, there's a big chunk of the test that has just you making these graphs, asking about is something tangent, does it cut through? Because today we're going to talk about polynomial inequalities. And one method to do polynomial inequalities is just to come up with a rough sketch and ask where is it below 0 and where is it above 0, just like we did with x squared. And in fact, that's what we're going to start off with. We're going to start off with quadratic inequalities to review those. Quadratic inequalities, the method that we used to do quadratics is we just came up with a rough sketch, and then we just asked ourselves, where is it below 0 or where is it above 0? So we're going to do the same thing here. So I'm looking at my lead coefficient. It's x squared. It's positive, so it's going to open up. It's going to be like a smiley face. All right, it's going to open up in both directions. So after I know that, maybe I'll mark that down. Because it's x squared, we do have a quick sketch. It is going to open up like that. Now I just need to find my zeros, if I have any. So we're going to go ahead and find our zeros next. That would be x squared minus 5x equals 0. I'll factor out an x to give me x times x minus 5 equals 0. So I do have a 0 at x equals 0 and x equals 5. I'm also going to note their multiplicity. We didn't when we did quadratics. We didn't really need to. We know if I have two of them, it must cross both of them. But if we quickly look, this is x to the first. This is x minus 5 to the first, which means it should go through both of those points because it's odd multiplicity. Let's go ahead and sketch this. Well, I have to get from 0 to 5, so let's kind of skew our y-axis because we know it's all going to be in the positive. So we're going to go 1, 2, 3, 4, 5. Mark that as 5. 0 there. 0 there. We start high and we should end high. We go through both of them because it's odd multiplicity. Boom. Now I go back to the original question. The original question is, when is this graph above or equal to 0? Well, above 0 is going to be anything above that line. That's where my y is bigger than 0. Is anything above that line. So let's just shade in that area. So my answer is anything that's shaded there. And we're going to use interval notation. So we're going to go from negative infinity, bless you, all the way to 0. And now when I'm thinking about bracket or parenthesis, I'm going to go back to the question. The question says greater than or equal to. Equal to tells me to use a bracket. So it's going to be negative infinity to 0 bracket. Union that with bracket 5 to infinity. We have our answer. Well, we could do the same thing with higher degree polynomials because now we know how to come up with a rough sketch of it. So if we just look at our bell work really quick, if I were to change this to when is this bigger than 0, you would just shade it in anything above the y-axis and you'd have your answer. All right, so we're going to do that exact same method, but with a slightly bigger polynomial. This is x plus 8 times x plus 2 times x minus 3. What power is this polynomial? Power is this polynomial? Teresa? It's x cubed, right? Now, here's a way to shortcut this. Yeah, it's super fun to distribute all that out and come up with your perfect polynomial. But remember, the only two things you care about, end behavior and your zeros. So all I need to know is my leading coefficient and where my zeros are at. We know where our zeros are at, right? They're at x equals negative 8, x equals negative 2, x equals 3. So let's go ahead and write those down first. So from this guy, we have x equals negative 8. We have x equals negative 2. And we also have x equals 3. And another key part about our zeros is we're going to look at the power, our multiplicity. Well, each of these have a multiplicity of 1. So they all have odd multiplicity. Maybe I shouldn't circle it, but just say odd multiplicity for all of them. They're all 1, which means it cuts through at each of those points. Well, now I need a leading coefficient. don't distribute everything. In this one, it wouldn't take that long, but I have bigger ones if you look at the test that have like high powers. All I want you to do is take this x. So we're going to do our very first multiplication. Remember, if you're doing like a binomial times binomial, you just do your first term times your first term. Well, if I extend this in a chain of things, we're just going to take our x, multiply it by that x, then multiply it by that x. Well, this is 1x squared times 1x squared times 1x squared, which comes out to 1x cubed. So we could rewrite this as just x cubed plus something is greater than or equal to 0. I only care about that lead coefficient because that's going to tell me whether it opens up, down, down, up. And since it is x cubed, it's odd, so it's either going to go like this or it's going to go like this. I'm looking at the lead coefficient is a positive 1. That means it has positive slope, which means it's going to go up like this. So based upon that x cubed, just a real quick sketch, we're going to have something that has end behavior that looks like that. And that's due to knowing that. All right, so I have end behavior. I have all my zeros. I know what happens at the zeros. So let's go ahead and make a sketch of this. I need to get from -8 to a +3. So let's kind of skew a little bit in that direction. I think I'm going to count by 2s, just to make it a little easier. Like go -2, -4, -6, -8. On the other side, we'll have 2, 4. I have a 0 at -8. I have a 0 at -2. I have a 0 at +3. It's odd and positive coefficients, so I start out down here. And I just work my way to my 0, and I ask, does it bounce off or does it cut through? Since the multiplicity is odd, it's going to go straight through. So we're going to go straight through at -8. I'm going to come back around to reach that other 0. -2, that's also odd multiplicity. It's x plus 2 to the first, which is odd. It's going to cut through. And finally, it's going to cut through at 3, because once again, that is x minus 3 to the first power multiplicity is 1. All right, now we go back to the question. The question is stated, when is this bigger than or equal to 0? That means when is it above the x-axis? Well, it's above the x-axis here and here. Now what we have to do is put that in interval notation. Well, it's greater than or equal to, so we are going to use brackets when we have numbers. So we'll have bracket -8 to bracket -2. And you'll union that with bracket 3 all the way to infinity. Infinity always uses parentheses. And that is our answer. All right, sometimes graphing these can be kind of cumbersome. Maybe it has a ton of different things. Maybe you forgot how odd even works. Maybe you can't tell the multiplicity. For whatever reason, maybe you can't graph it, or it's going to take you forever to graph. Just remember, I really don't care what value these are. I only care that this is positive, this section's negative, this section's negative, and this section's positive. I just want to know, in this section, are all those numbers positive, or are all of them negative? Well, at the end of the day, we can just check those. We can say, okay, at -9, plug in your calculator, what value does it come out? Does it come out as negative, or does it come out as positive? I could plug a -3 and see if it's positive or negative. I'm just going to check each of these intervals to see if it's positive or negative. That way you don't have to do a graph. You just got to check a bunch of points. That is the test point method. This is when you just can't make a rough sketch, or you just don't remember it, or maybe I didn't give you enough information. Maybe I didn't say there's an odd multiplicity. Maybe I gave you a long equation. I just said you have zeros at 2, 3, and 4, and I don't tell you anything about multiplicity, in which case you would have to use this method. Well, this method just has a few steps to it. Notice we aren't making a graph, so I don't need to do a leading coefficient test. All I'm going to do is I'm going to find my zeros. That's the first step in test point method is just find all of your zeros. Well, all of our zeros for this one are going to be -8, -2, and a +3. I don't even care about multiplicity. With test point method, all you're doing is you're finding your zeros. And then I'm going to create a number line real quick on the next screen so I have a little bit more space. But I'm just going to draw a number line that has those 3 values on it, and it doesn't have to be a super accurate number line. So it's -2, -8, and +3. This is all we need for a number line. We just need to have a -8 on it, and make sure you just have it kind of in order. We had a -2, and we had a 3, yes. I don't care how accurate you do your number lines. All I care about, picture a polynomial, right? Say I have a polynomial going like this, and it cuts through like that. That means all of these would be positive. Maybe I'll draw this on here. So I'm just basically checking, does that go up? Or does that go down? From -2 to 3, does that go up? Or does that go down? And then I also need to check, well, does our graph go on forever that direction? Or does our graph forever go on that direction? So on each of those intervals, we're just going to pick a point and see if it's positive or negative. So what I'm going to do is I'm just going to pick a point here. I'm just going to pick a point that's less than -8. I picked f of -9. Now what I would do is I would take out my calculator and plug it in the equation. -9 + 8 times -9 + 2, -9 minus 3. And that's going to result in, I got the wrong one up. If I plug in -9 in here, I should get out a -84. Here's a little shortcut. Here's a little shortcut, so pay attention to this. All I care about is the fact that it's negative. All right, now I know my line kind of does that. Since I only care about negative or positive, what you can do is you can just look at this. You can go, okay, -9 + 8 is a negative. -9 + 2, that's a negative. -9 minus 3 is a negative. That's a negative times a negative times a negative, which is going to come out to be a negative number. So you can do that. Otherwise, just plug in your calculator, come up with -84. I know that little section is negative. Now let's pick a number between -2 and -8. You could pick anything. You pick -3, -4, -5, -6. I ended up picking f of -4. And I got out a positive 56. Which means the interval between -8 and 2 is a positive. And I typically just do this negative positive thing. You can list it however you want to. I just like to visually see that's above and this is below. I want you right now just to pick these two values and decide if this is positive, negative, or if this is positive and negative. All right, real quick, between -2 and 3, is our graph positive or negative? Liam?
Negative.
It's negative. What value did you plug in?
0.
You plugged in 0, so you did f of 0. Did you actually get the total, or you just come out that it's negative?
I just got that it was negative.
Cool, that's perfect. Did anyone get the value for where if I plug 0 in?
48.
You got what?
-48.
-48? That's what I got too, yep. But like, Liam, you didn't even need a calculator, right? You could have just, you realize it's just negative,
Yeah.
negative, and then it was positive. All right, and then our interval from 3 to forevers, did anyone get that as negative or positive? Help. Somebody.
Positive?
Positive, thank you. What value did you plug in?
4.
You plugged in 4. Did you get an actual value? You just know it's positive.
I got 72.
F of 4 equals 72. Yep, I got 72 as well. Well, although you don't need to do this, you can kind of picture what the graph looks like now. If anything less than negative 8 is negative, you could kind of picture that graph doing something like this. Coming through, going positive, coming through, going negative, and going positive. What that means for you, let's say you're in the section that I say graph these based upon this information, and you forgot what odd power did. You forgot what even multiplicity did. Just plug in a couple. How many points did I plug in? 1, 2, 3. I plugged in 4 points, and I know what the graph looks like. At the end of the day, you can just plug in 4 or 5 points and know exactly what the graph looks like. This is great to know in case you forget what the basic shapes look like. You can just check it. All right? Easy way to check. But in this method, we are supposed to answer that question. We are looking for, I already forgot if it's greater than or equal to. It is greater than or equal to 0. So that is, when is it positive or equal to 0? Well, it's positive on the interval from negative 8 to negative 2. It is greater than or equal to, so we're going to use a bracket, negative 8, comma, negative 2, bracket. Union that with bracket, negative 3 to infinity. Now, the great question was in class today, they asked, on the test, am I going to make you use one of these methods? I will not. I will just say, solve this. However method you want to use, go ahead and solve it. Yes? Did I put negative? Yeah, it should be positive. Yep, positive. 3 to infinity. Thank you. Because that is a positive 3. I think I just saw that negative sign up front, and I just decided to write it for some reason. Any questions on anything we did today? Okay, then questions from the homework. Yeah.
41.
All right, 41 is asking us to graph x minus 1 squared plus or times x plus 3. So what I'm looking at is, well, x minus 1 would give me, maybe I'll write this down. So we have f of x equals x minus 1 squared x plus 3. Well, what I'm looking at are my zeros. Well, I have a 0 at x equals 1. And I also have a 0 at x equals a negative 3. And what I'm also doing is I'm looking at the powers. What is their multiplicity? So this here is even multiplicity. This here is odd multiplicity. So that means at x equals 1, since it's even, it's going to bounce off it. It's going to hit it and it's going to bounce off. If it's odd, it's going to cut right through it. So at x equals 1, it's going to bounce off. At x equals negative 3, it's going to go right through. Now, in order to come up with my graph, I need to have my leading coefficient. So I'm going to rewrite our f of x really quick. But all I need to do, and the homework, I actually distributed it all out pretty much. But look here, this is just x squared, right? If I actually did this, this is x squared. This is x to the first. Well, this would just be 1x squared times 1x to the first. So we could rewrite this, if I did the full distributing, as just x cubed plus something, 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 something. I don't care about the rest of this stuff. All I care about is my leading coefficient and my zeros. So based upon the fact that it's x cubed, our end behavior is going to look something like this. It is odd, so it either goes up, down, or down, up. Since there's a positive 1, it would have positive slope. So we'd have end behavior that looks like this. And so our finished graph would look something like this. We have to get to -3 for one of my zeros. So 1, 2, 3, -3. Let's go ahead and put a point there. Then we get up to 1. Well, at 3, it's going to cross. At 1, it's going to be tangent because we had x equals 1 was that even one, so that's tangent. And so our graph is going to start low, cross through -3, bounce off there, and look something like that. So your key on all these is to find your leading coefficient, find your zeros, and ask what multiplicity it has. Even multiplicity, it bounces off. Odd, it's going to cut right through. All right, other questions from the homework? Think this will be enough for the next one?
Sorry, what?
Is there going to be enough information for the next one?
Yeah, I think so.
Okay. Other questions? Questions? All right, I do want to go over something.